because I am teaching a double lesson, I need to make a new video, so behave, okay? So your calendar, I don't want to change all of it, but just so you know, we're going to get through 6.1, which is really very easy. I think I can tackle that in like 20, 30 minutes tops. And then 6.2 is long division, and that is going to be new. It's not exactly the most fun thing ever, but it is something that we got to do. And then Wednesday, my plan for y'all, like I said, is just to work on the homework. And then we have a CFU over 6.1 and 6.2. I'm going to have y'all take that at the end of class, just to kind of see how you do. So B-Day, y'all are going to be a little bit off schedule, but that's okay. We'll figure it out. So I'll leave with the sub. I'll leave an answer key. I'll have her pass out the homework, leave an answer key for you to check. I'll include the work on it too. So that way, if you get stuck, you can at least look at that. And then, yeah, you'll do the CFUs at the end. Not passing back Unit 5 tests just yet, but those test grades are in Hack, so you can see I did lay out everything through the end of the quarter and the semester, so you know when stuff is. Unit 6 is kind of short, so some of y'all said the packet was small. The packet only goes through 6.3. The 6.4 notes, it'll be just like an added thing. We'll staple it. But we decided to put that lesson in before. But your final grade, which there are 3, will be the test on December 11th. And it will be 3 different topics. So you should end up with 7 grades, I believe, total. You have 4 right now. So you should end up with 7. Yeah, so that's what we got. And then we'll do some stuff kind of towards the end that we don't have time to do a test on it, but it is something that we need to know how to do in practice because they will expect you to know it in pre-cal. But reassessments are all going to be these 2 days, so be ready if you are reassessing anything. Okay? So all that's on Canvas, but yeah, we got to kind of knock out these 2 lessons. So I'm probably going to skip some stuff just for time. I'll get everything worked out on Canvas if you want to go back and try some extra problems, but let's close our Chromebooks. Everyone, let's give me your attention, and we are starting our next unit on polynomials. Okay, don't talk over me. All right, so here's just a little intro on the front page of what polynomials are. So it's a polynomial function. It's a function that involves only non-negative integer powers. So what that means is that the exponents are positive whole numbers, okay? So, like, you can't have, a negative exponent. That wouldn't be a polynomial. It's only like x to the second, x to the third, so on and so forth. And you've seen a lot of polynomials at this point. Quadratics are polynomials. Some of the ones that you haven't you maybe have seen but haven't really studied, which we will do a fair amount with cubic equations. But here's some examples for you. One thing that I did want to talk about is a vocab word that I will be mentioning is the vocab word degree. And what that is it's the highest exponent that the polynomial has. Typically in standard form, you put your highest exponent in the first term and then descend from there. And so you could just look at what's the biggest exponent, that's the degree. But I will talk about that highest exponent of the polynomial. So for example, here's a quadratic equation. That is a polynomial. Again, your exponents are positive whole numbers. This is in standard form. So quadratics, what's their degree? Their degree 2. Okay. This one right below, the horizontal lines there, that's exciting. But here's a cubic graph, which we will transform these at some point this semester. But this is a cubic. Cubics are degree what? Degree 3. And then this last one is the last one that has like a special name, and that's degree 4. That's a quartic. After that, they just kind of go with polynomials. But what's interesting about the degree, and this is kind of, we used to spend a lot more time like graphing these and stuff, but they've taken that out of Algebra 2. It is something you'll see in pre-cal, and it makes me sad because they were fun to graph. But the degree tells you the maximum amount of roots that something can have. So like a quadratic was degree 2, and that's why our cases for number of roots were 0, 1, or 2. You could never have more than that. So like a cubic could have up to 3 x-intercepts. A quartic could have up to 4, but never over what that degree is. 2 characteristics of a polynomial. It contains only smooth or rounded curves. So like absolute value, they have that sharp turn. That's not going to be a quadratic. So that's a polynomial. And then it also is continuous. So like you can draw your polynomial without having to pick up your pencil is what that means. There's no asymptotes. There's no discontinuities. There's no place that it stops. And then this is kind of what a polynomial looks like in standard form. I know it looks like wild with all the letters everywhere. This says f of x. It just got a hole punched out. The a's, the a sub n's, those are just coefficients. So like I know that looks weird, but those are just like 2x to the 4th minus 5x squared, like things like that. And then your exponents, again, when you're in standard form, you want to go in descending order. So whatever that highest exponent is would be in the first place, and then you would just descend from there. So that's what like n minus 1 means and whatever. And so you'll go like 2, 1, 0. But those are your polynomial characteristics there. Pretty much all we're going to do, like I said, the scope of this in Algebra 2 is we're really just dealing with the operations. And we are going to cover, you guys, we're going to cover all 4 of them. Adding and subtracting is kind of an Algebra 1 skill. It's really easy. Multiplying, also an Algebra 1 skill, very easy. It's the division that is going to take a couple days because there's 2 types of divisions. We're doing the worst one today, long division. It's going to take longer. And then you'll practice with that. And then when I get back on Friday, I'm going to teach you a shorter division that works sometimes but not always. So that is the plan. So join me on page 2. The first thing we're going to do is adding and subtracting polynomials, and this really should be easy. You are going to get a calculator because for the higher divisions it's helpful, but you shouldn't really need it because all you're doing when you add and subtract polynomials is combine like terms. That's essentially all it is, combining like terms. I abbreviate that CLT. Adding, you don't even have to have any sign changes. Subtracting is the only one that you do have to change. You want to put it in order from the highest degree, so the largest exponent to the smallest. It may not, you don't have to like put zeros in if it's missing one. You just kind of work your way down. The only thing that changes is the coefficients. The variables and the exponents will not change in add, subtract. And then we'll just do a couple of these here, and then we'll get to the multiplying because I assume we can add. Technically, the instructions are going to say, like, simplify for a lot of your operations. It's up to you to determine the type of problem that means. This one is just put it all together. So what's the highest exponent on number 1? 4. And I have 2 terms that have an x to the 4th. So I underline those, and I'm going to put those together. What are those going to combine to be? 8x to the 4th. And I always like to mark them out when I'm done, so that way it's just less to look at. And so I'm like literally just putting like terms together. Only have 1x to the 3rd, it looks like. So I'm just going to bring that down. Doesn't change. My x squareds, and I do the little shapes. This is how we do it in Algebra 1. You don't have to do that. I'm just, whatever. 4x squared plus 6x squared is 10x squared. Done with those. And then it's just minus x plus 2, and then that's my answer. Done. Addition problems. This one, like, spells out in words, add this to this, but it could look like, you don't have to write this, I can just show you. It could just say, like, here is a polynomial, minus 12, plus, I think this is how it is more like on the homework, so just so you're aware, x to the 7th plus 4 minus 2x cubed. It could just be like polynomial plus polynomial. The parentheses with addition, again, that sign in the middle is important. The parentheses don't matter. So you don't even have to, like, you can ignore them, you can take them away, you can just work the problem from there. But again, you want to go in descending order. Let me talk about 3 real quick to set up, and I'll let you guys try these on your own because they are really easy. But look at how, everyone take a time out and look at how number 3 is set up. First of all, let's review some words here. What is a sum? What does that mean to do? To add. What is the difference? To subtract. If it says sum or difference, you just go in that order. There's a problem on the homework that 8A, I had a ton of people asking me the question. They said it said find the difference. It's just this guy minus this guy in order. This one is a little bit different. I think this is why they were a little bit confused. This one says to subtract this polynomial from this polynomial. Are you going to go in order, first minus second, on this one? No. Okay, so this one, you're taking this guy from this guy. So I'm going to write it out. 7x cubed plus 13x minus 8x to the 5th plus 20x squared minus negative 2x to the 5th plus 3x squared, cubed, minus 9x squared plus 5. So you do have to switch the order with that wording, but if it just says like subtract or find the difference, you don't have to worry about that there. Be careful. Subtraction problems, you've got the extra step. You have to distribute the minus sign to everything that comes after that subtraction. So that's going to change the sign of every single term in that second parentheses. And then after that, it just becomes a combining like terms. So take a minute, try these couple of problems. I'll put up the answer key, and that will conclude adding and subtracting. And we'll jump to multiplying. Is number 2 and 3 I have up here. I'll slide the paper up in a second. Again, I kind of showed a lot of work on my answer key. You don't have to have as much work as I do. Just trying to show all the ways. I do want you to make sure you kind of put everything in descending order. Is good here, but really I'll slowly slide this one. Then it's not in standard form. But again, y'all, there's really especially since you are going to get a calculator on this whole test, you should not be making mental math mistakes and things like that. So just be thorough. Don't speed through these. It's annoying when people miss these questions because they are they're just really easy. And I think sometimes people just move too fast. More of an issue with the subtractions. Distributing that minus sign all the way in obviously is important. So, yeah. So the other thing that will be on the first topic of this test, it will include add, subtract. The other thing will be multiplying. Now, multiplying, again, still, we have these two. Well, these are kind of a combo of add, subtract, and multiply. I do like these. These are good. You have some questions like this on your notes. I think she called them, instead of calling them f of x and g of x, she called them A and B or something, but, either way. So you have two different functions, and it wants you to find 3f of x minus 2g of x. So this is, technically a subtraction, but what do you do? How do you do this? What do you think? What is f of x? So you multiply 3 times. Oh, yeah, you need the instructions for sure. So 3 times 3x minus 7 minus 2 times g of x is the trinomial. And it's a transition between a little bit of multiplying and then subtracting. So you are distributing here and here. And we're distributing here. So this is 9x. Watch that negative. Think of that as a negative 2. So negative 2x squared plus 8x minus 10. And then again, I do want these in standard form. So highest exponent goes first. 2x squared. Combine your x's. 17x. Combine your constants. And then that's your answer. So another thing that I do want to point out about this too is everything we've been doing is just simplifying expressions. What's the difference between an expression and an equation? equations have equal signs. So a lot of these problems are just going to say like simplify or do the operation or whatever. And if it's not originally an equation, then it's not going to end up being an equation. There are a couple equations on here we're going to get to on the next page, but these are all expressions. Okay, let's do 3g of x plus f of x squared. I like this one. So we have to multiply g of x, which is the trinomial. Okay, that's just like the other side. But what do we have to do to f of x? We have to FOIL because it is a binomial squared. So yes, you do have to FOIL this out. So I'll do that up here, which means write it twice. 3x minus 7, 3x minus 7. And then multiply that out. In multiplying, y'all already know this because we've done FOILing. We did it in the quadratics unit several times. But your exponents do change. So this is 9x squared minus 21x minus 21x plus 49. And then if I multiply this in here, 3x squared minus 12x plus 15. This is in addition to that. I'm going to combine these two so I don't have to change any signs. And then my final answer, 12x squared minus 54x plus 64. Not bad. Are we okay so far? Okay. So the next little section, we're going to skip 10. 9 was like literally on your last test, a problem just like that. What's the key to dealing with number 9? What do you do first?
Multiply the ones that are the same.
Multiply they're the same but different. One's plus, one's minus. Multiply the conjugates first. That is how you make this problem easier. And then you get a whole number, and then you just distribute that through. So do that one real quick, and then I want to talk about 7. You try 8, and then we'll jump to, we still have a little bit more in this section, and then we'll get to long division. So try this out. So this will be 1 plus 4i. One thing that did happen on this test, shush. One thing that did happen on this test with the i's and dealing with the complex numbers and multiplying like that, which does, I mean, even if it doesn't have i's in it, you're still going to have to do this. Y'all have to make sure that you're multiplying the coefficients. So like some people, like this is a 4i and a negative 4i. That's got to be negative 16i squared. Some people just squared the I and like left off the coefficients completely, which is wrong. And what is I squared? Very good. Remember that from over break. So this becomes 1 minus 16 times negative 1, which becomes 1 plus 16, which is 17. And then multiply that, and it just becomes a real easy distribute. Okay. Yeah. Yes. No. 7 and 8. This is, again, I took off 10 because we're going to kind of do that on the next page. 9 was on our last test. Good review, especially if you're retesting. Topic 1, you'll need to do that. But 7 and 8. This is kind of more like what you're going to see on this next test. As far as like multiplying, we FOILed a lot. Binomials times binomials. We are going to see binomials times trinomials and trinomials times trinomials. I do prefer to make a box with problems like these, and I've showed y'all the box before. There was i's in the mix, but it's kind of the same thing on number 7. But as far as like the multiplying type problems on this first topic, they are going to be like bigger polynomials, as in like a 2 by 3 or a 3 by 3 is probably not just going to be like a plain old FOIL problem, just FYI. The other thing that's weird about 7 and 8 is the quadratic. The trinomial isn't in standard form, so I'm going to rearrange that as well. But I'll do 7, then y'all can do 8. So I'm putting my binomial kind of on the side, and I'm going to rearrange and put standard form. I don't really know why it's not in standard form, but it's fine. I know you can still get the right answer even if you don't do that first. I just prefer to. But this will be a 2 by 3 multiplication. And remember, with multiplication, your exponents are going to change. So you're multiplying the coefficients, and then you're adding your exponents. So 2x squared times, that's 1x to the first. What is that going to give me?
2x to the third.
2x to the third, because 2 times 1 is 2. 2 plus 1, when you add up those exponents, that gets you to the third. I'm going to continue this row. Negative 4x times x is negative 4x squared. It's not a trick question. And then 1 times x is positive 1x. My next row, I'm just multiplying by 2, so this will be 4x squared minus 8x plus 2.
Oh, see, that one was chill.
And then it's not crazy difficult,
No, it's not too difficult.
but it is easy to get kind of lost in the work if you don't keep it super organized.
For sure, I think we definitely see this.
So check for like terms. There's no other x to the third. Your x squareds end up zeroing out, so you don't have to put that. You can combine here. This will be minus 7x plus 2. Yeah.
If you flip it around, won't you?
Here's number 8.
Oh my goodness, this is too light.
Okay, when you're done, flip over. We're going to do 11 and we're going to do 13. The other ones are kind of duplicates, so. Any questions on the multiplication so far? So, to review, we have done adding and subtracting expressions. That's combining like terms. We've done multiplying expressions. That's just multiplying. Again, box it, FOIL it, depending on your size. Now, the next type of problems, they still kind of fall under the multiplication category. They are both worth starring. And again, 11 and 12 are kind of repeats, so I'm just going to do one. 13 and 14 are repeats, so I'm just going to do one of those. You're going to see some of these on your homework, so when you're practicing, if you're confused, look back here. I promise everything's in the notes. That's what I would tell you if I was here. I would say go look at page 4 and look at number 11. Number 11 was actually on your last quadratic test, one just like that, and I had a pretty large handful of people like either leave it completely blank or totally botch it, and I know we did it. Now, first of all, let's look at what the instructions say to do. So they give you're going to have a quadratic equation. So your equation's going to end up with an x to the power of 2 because it's quadratic. Now, you're writing an equation, and those of you that made 99s on your test, guess what you probably did wrong?
Oh, you didn't write y equals.
You didn't write y equals, and I hope that 99 hurts, okay? So it says equation, so go ahead and put y equals just at the bottom of the page because you know it's going to be y equals. Now, here is the key to these problems. There are 2 roots. You need to recognize that this is 2 plus 3i, and what's the other one?
2 minus.
So that's the first thing, is be able to, whether they put it together, you can take it apart. Set x equal to your roots, whether they are real or imaginary. This will be how we start every single problem, and a lot of you left this off. A lot of people were just multiplying those conjugates and getting like a nice number. Okay, great. Not what you're supposed to do. So you need to start by setting x equal to every single x-intercept that you have. We're going to get more on number 13. Then you need to turn those back into a factor. So you need to move stuff back over. So this factor would be x minus 2 minus 3i, because that's what I would do to move that positive 2 and positive 3i. This factor will be x minus 2 plus 3i. And then this is your factored form. So to get to your standard form, you just multiply it out. This is like a trinomial times a trinomial. So I am going to do a 3 by 3 box. A lot of weird xi, ix, yada yada, that stuff's going to cancel out. And then I'm going to fix my I squareds. But we have done this before. And again, if you are retesting, like, make sure you do know how to do this because it's not going away.
I have a question.
Yes.
Is it always -2? Like, and then both of it?
Yeah, the front number should be the same on both of them. And
No,
it's
but,
the
like, is it
opposite. No, because if the root was at -2, then it plus or minus 3i, then it would be x plus 2.
Okay, but
Like, it just
standard-
depends on-
the standard, it's -2.
Well, no, it depends on what the root actually is. Like, if this was x equals -2, then it would be x plus 2 minus 3i. Minus 2.
Didn't you get a 20 on your test, Marth? Yeah.
Okay. Okay, so after you do the multiplication, after you do the multiplication, the i's should either I squareds become -1, but then anything that has an I in it, like, it should simplify out. So the 3ix and the -3ix, those zero out. The 6i, the -6i, those zero out. And then we know that I squared is -1. This is another time that we missed. I had some people miss that multiplication. It's got to be 3 times -3, -9 I squared, which is going to become what? This is going to become a positive 9 because it's -9 times -1. So then you combine your x's, you combine these two real numbers, and your equation ends up being x squared minus 4x plus 13. Because again, when you started with your quadratic equations, you didn't know if it had real or imaginary until you found the discriminant. But they all looked, normal looking quadratics there. So 12's a repeat of that. We'll skip that. 13, the only thing that's different about 13 is that it just says a function has roots of 5 and plus or minus 3i. How many roots do you have in this problem? 3. So it's not going to be a quadratic, okay? It's going to be a degree 3 or higher. It'll be a degree 3 because these roots aren't real crazy. But you're basically doing the exact same thing. You're setting x equal to each root. X equals 5. Oh, I'm going to put my y equals because it's an equation and I don't want a 99. So x equals 5. What else does x equal?
-3i and positive 3i.
-3i and positive 3i. Okay, there's one like this on the homework, so make sure that you separate that out. Then write it back in factored form. So x equals 5 will give me a factor of x minus 5. X equals -3i gives me a factor of x plus 3i. My other factor is x minus 3i. What's the smart way to start this problem? Do the conjugates, okay? And you can FOIL because this is a binomial times a binomial. 2 terms times 2 terms. So that will give me, I'll write it all out, x squared minus 3ix plus 3ix, which drops minus, which we already know that is
Plus 9.
x squared plus 9. So now I'm going to multiply x minus 5 times x squared plus 9, which I still can FOIL because it's a binomial times a binomial. I want to put it in standard form, so I'm going to be smart about, I'm not going to actually do it in order of FOIL. I'm going to switch up the order a minute. But x times x squared is going to give me x to the third. Okay, I'm actually going to do the inside terms next because I want to do that. I want the squared to be next. So this will be minus 5x squared. What's the next term going to be? Plus 9x. And then the last term is going to be, are you okay if I went out of order? If you went out of order, if you didn't, you would just have to rearrange it at the end, but it's all good. Okay? So, through these problems that we just did, that will be its own test topic. Add, subtract, multiply, writing a little bit of equations. All right, we will take a 3-minute brain break, and then we're going to learn long division. We're now on section 6.2, okay? So to review, next class, you're going to get your homework page. You have to do 6.1. I believe it is 9 problems. 6.2 is only 3 problems because they take a lot longer. And then you're going to take a check for understanding at the end of class over each. It'll be 2 half sheets, and I'll just tell the sub to have y'all staple it. Long division is new, so if you are just like over listening to me talk, you're going to have to get over that because you need to hear me explain this. It is not terribly hard to do. It is just long. It's long division, okay? But the process itself is very repetitive and very, again, it's not hard. But we just need to make sure that we kind of talk through some vocab and then go from there. I'm not going to do all the examples. I'm not going to have time to do all of them. But I will get everything worked out on Canvas. And it'll be on the division day. Anyways. Okay, so there's 2 types of division we're going to learn. We are going to learn long division today. Friday, you will be happy when I teach you how to do synthetic division because it is a lot quicker, but it does not always work, so save that for Friday. But the first thing is with either method that you do, and we're not really going to see this till the end of the lesson today, but you need to make sure that what you're dividing by, both parts, the dividend and the divisor, I'm going to go over those vocab words in a minute, are always in order from highest degree to lowest degree. And you do, when you're doing division, have to put a placeholder. So if my problem said 2x to the 4th plus x squared, I'm missing an x to the 3rd term. I have to write 0x to the 3rd in the middle. That's very important in division that you get that step. It really does matter. And we'll see it. We're not going to start out with that, but I want to mention that. Then, these steps aren't going to make sense, so I'm just going to jump into it, but they did a worked out example for you. I just kind of want to go over vocab here first thing. Most of the time, it will be written like this, and it has the little division thing. But keep in mind, it could also be written like this. X to the 3rd plus 3x squared plus 3x plus 2. It could be written as a fraction. That also means division. Or it could just say, divide this by this. There's kind of different ways that we can explain it. But the dividend is the one that's on the top or the one that goes first, okay? It's usually, that's going to be the higher degree is your dividend. Your divisor is what you're dividing by. So it's on the bottom or it's in the second place right there. So I always get those vocab words forget which one is which, but I think of it as divisor is what I'm dividing by. And then it is long division. I don't know if y'all learned that or y'all did that weird 7 thing when you just divided big numbers, but either way, it's kind of got this little house shape thing here. And then here we go. So let's just jump into an example and I'll kind of go through the steps one by one. Again, and it's a repeat. You keep doing the same 3 or 4 steps over and over and over again. So it says, what's the result when x squared plus 5x minus 14 is divided by x minus 2? So this is your dividend. This is your divisor. Okay? Check your dividend and divisor. Who's next in the bathroom? You can go. Check your dividend and divisor before you do anything. Look and make sure, check for needing placeholders. So you need to make sure those exponents start at the greatest and every single one is covered. So I have an x squared then I have an x to the 1, then I have a constant, an x to the 0. Do I need a placeholder here? No. Do I need a placeholder here? X minus 2. Nope. It's an x to the, it's whatever it's not in comparison to this one. It's in, like, just in the order. So whatever goes first, you won't, you don't need to go there. Your dividend does need to be a higher degree than your divisor, or else it's not going to work. Okay? So no placeholders, good to go. So your divisor is going to go on the outside. So I'm going to have x minus 2 right there. My dividend is going to go on the inside, which your dividend is usually the one that's like written first, but it goes kind of like inside the little house. The divisor goes on the outside. And then here's how this goes, okay? I'm going to take the first term of the dividend, and this is my side work over here in red, and I'm going to divide it by the first term of my divisor. Just like do a quick little quotient over here with just those first guys, ignoring the rest of the stuff. So x squared divided by x to the 1, what is that? That's just x, okay? If you had coefficients, you would divide the big numbers. You're subtracting the exponents. So I'm going to put this little mini quotient up at the top of the house. So I'm going to put an x right there. That's an x to the 1. 1x to the 1. And I line mine up with like the term below. Like these are both x's, so I leave that there. Okay? We okay so far? Let's do a little mini division. Then I'm going to take this guy up top and I'm going to multiply it to all the parts of the divisor. So x times x is x squared. X times negative 2 is negative 2x. But here's what's kind of tricky about this step. You have to subtract that product. Okay? So I kind of have a workaround for this, but I want to just show it to you like slowly. You end up subtracting these guys. So what kind of x squared does this guy end up being if you distribute in that sign? A negative. And what kind of 2x does this end up being if you distribute in that sign? A plus. So I distribute that in, okay? What should happen? Just hang with me because it's going to repeat. Every single time you do your long division, this first term should become 0. What is x squared minus x squared? 0. If it does not go away, you have made a mistake. Okay? And then I'm going to do 5x plus 2x is what? 7x. And then I'm going to bring down the minus 14 to my next level right here. Okay? And then it starts over. You're now pretending this is your original guy in the house. So I'm going to take this term, first guy, 7x, do my little mini quotient. What am I going to divide that by? X right here, the first guy over here. 7x divided by x is 7. So watch, I'm going to put a plus 7 at the top. Now, here's what I do because I don't like having to distribute a minus sign. I do the multiply and flip. So watch what I do right here. 7 times x is what? But I'm going to have to distribute a minus sign. It's a positive 7x. But when I distribute a minus sign, the sign's going to flip. So I'm really going to get a negative 7x. 7 times negative 2 is what kind of number? Negative 14. But when I flip the sign, what do I really have in here? A positive 14. I kind of do that sign flip in one step just to try to take work out. But I'm multiplying and then writing the opposite sign right there. Yes.
Is it okay if you don't do the sign flip?
It is.
You
Just,
write the minus?
that is fine. It's just, this is the term that I worry about. The minus sign often does not get to the second term, which is going to cause you problems. So just be careful, okay? But if I go ahead and do it like that, now I just set it up as a sum. And to me, I think that's easier. Not the only way to do it, though. 7x minus 7x is gone. as it should. And negative 14 plus 14 is also 0, gone, as it should. And when you don't have any more terms to bring down, this guy is called your remainder. And if the remainder is 0, then that means it divides evenly. That means the divisor is a factor. We'll talk about that on Friday. And your answer, what are you finding if you're dividing something? Quotient. Very good. Sometimes we throw that word out and everybody freaks out. Quotient means divide. Your quotient is what's up at the top. So the answer to this problem is x plus 7. What was your question?
I was gonna ask if there's a remainder.
Number 2. Let's go to number 2. We're going to see a remainder on number 2. I promise this process gets easier. It's one of those things that you just have to do. You just have to do kind of over and over until you get it. But then it's just annoying. All right. What is the result? Here we go. X squared minus 2x minus 48 is divided by x minus 6. The first thing is I'm looking for placeholders, one at a time. X squared, x constant. I'm good. X constant. I'm good. Okay, so now set up your little house. X minus 6. These also take like a lot of paper too, so just FYI. And then x squared minus 2x minus 48 goes inside. Okay? All right, my first step is to do just a mini division between the first terms. X squared divided by x, which is x. X goes at the top. This is the tricky step. This is multiply, flip the sign. X times x is positive x squared. Gotta flip it. I'm going to write negative x squared. X times negative 6 is negative 6x. Gotta flip it. Gonna write positive 6x. And then I add these up. Are we okay? The first guy should always, always, always zero out. That is the whole point. Negative 2x plus 6x is... And then what do you do next?
Oh, 4x divided by x.
Bring down, okay, here's the thing, because we're going to see this like in the next couple problems. You only bring down one term at a time. Right now we only have one term left, but don't bring down everything, just one term at a time. And then you start over. 4x divided by x is... Positive 4, multiply, flip, multiply, flip. First terms cancel out. The second do not. So I have a negative 24 right here. Do I have any more numbers to bring down?
No.
So I'm done. What is your remainder here?
Negative 24.
So let's talk about what that means. What I divided by. If the remainder is not 0, this guy is not a factor of the original. If you kind of see where we're going, this is going to help us factor, okay? So if we get something that divides evenly, then that is saying, hey, what you divided by is a factor. The quotient is the other one. This is not, because my remainder is not 0. So here's how you write it. It's written right here, which looks weird. But my quotient, my answer, quote, is I still need to take the expression from the top. So I'm going to have x plus 4. That is the q of x part from the top. But then I'm going to add the remainder, which is negative 24. You could put a minus sign, but I'm just going to put plus negative. So take whatever that remainder is. It might be a number. It could be an expression. And then I'm going to put that, only the remainder, over the divisor, which is x minus 6. And this is my full answer. Okay? So this is the part that's at the top of the house. This is the divisor. And this is the remainder. That's where that came from. So the answers just like look kind of yucky, but that's how you put that all together. Sure. Let's try 3 together. No. Let's try 3. Or actually, y'all want me to just kind of work 3, and then if you get stuck, you can just kind of look up here and see what I'm doing? Okay. Okay, just FYI, this is going to have more steps, more levels than our last 2. I know that because these are 2 degrees apart. This is an x to the 3rd divided by an x to the 1. The further apart the dividend and divisor are in degree, the more levels of long division you have. So just FYI, it's going to be a little bit longer. You might want to write a little bit smaller. Your first steps are still the same. First divided by first. But what is this? What's 2x cubed divided by 2x? X squared. Yeah, 2 divided by 2 is 1, and then subtract the exponents. Still do your multiply and flip. So this is going to give me negative 2x cubed. This is negative 3x squared, right? Positive 3x squared. And then I add them up. 2x squared. And this is what I'm talking about right here. Only take one thing down at a time. So I'm only bringing down the minus 11x. I'm leaving the plus 12. I'll bring that down later. So that kind of helps you keep track of like when to be done. Yes?
Why for like, when you figure out what would be like on top, why did you divide, I guess, 2x cubed divided by...
First term divided by first term. First term of the inside divided by. So then when you get to the next level, you're doing the same thing. This time I'm doing a negative 2x squared divided by positive 2x. So what is that?
Negative X.
Just negative x. Negative x. So this will be negative 2x squared. Flip it. Positive 2x squared. This will be positive 3x. Flip it. Negative 3x. Just be careful with the signs. Yeah.
So every time you like subtract from like the divisor current, do you end up like multiplying whatever divisor with like yeah, whatever's at the top.
Yeah. You're multiplying by the outside. But then you're changing the sign.
Yeah.
Multiply and flip. Multiply the numbers, flip the sign. So do y'all see how this problem has more layers, more levels? I'm yet doing another beginning term divided by beginning term. Yet again. And this is happening because my degrees are further and further apart. And this is going to be negative 7. Negative 7 up here. Negative 14x, flip it, positive 14x. Positive 21, flip it. This is annoying. Yes, we can agree.
Wait, I thought instead of negative x, I got positive x.
You lost the sign somewhere.
Oh.
Wait, how?
Shoot.
I got negative 9.
Y'all gotta be careful with the mental math here because one small mistake is gonna derail all of it. Okay, so this one, hang with me. I'm just gonna try to do 2 more problems with you. 2 more problems after this, okay? Remember, I'm not gonna be here Wednesday. I don't know if you're gonna be able to figure this out on your own. So please listen, okay? your answer, you do not have to write quotient. I always just kind of write that as my answer, but technically it's just this. What's on the top of the house plus the remainder over the divisor. If the remainder is 0, you do not have to write that little last step. It's just what's at the top. But a lot of times you do get ones that are not like that, okay? So questions so far on 3. All right, I want to do 5 and I want to do 6. 5 and 6, okay? 4 is great, but 5 is fine too. And 6 goes over a placeholder, okay? All right, so go to 5. We're almost done. Pipe down. All right, what is the result when this guy is divided by this guy? Okay, this is going to be multiple levels because what's the degree of the dividend? What's the degree of the divisor? 2. So they're kind of far apart. So we're going to have a little bit more work. Okay, 2x squared minus 3x minus 2. 8x to the 4th minus 16x cubed minus 12x squared plus 19x plus 10. FYI, this is a problem that you would have to use long division. Have to. The shortcut does not work if your divisor is higher than degree 1 or if you have a coefficient on your divisor. What we're learning Friday. So I'm just telling you, like, there's going to be problems that are kind of like this that you have to do long division so that way I can test you on it. Okay? We do not need any placeholders, please. What's a placeholder?
0x to the...
Right. So I don't need one here because look at the exponents. 4, 3, 2, 1, 0. Nothing's missing. A placeholder would be like if I went 4 to 2. I would have to put 0x cubed. In the divisor, it goes 2, 1, 0. I don't need a placeholder there. We're going to see that. It's more with synthetic, which we'll learn Friday. But it's just important, okay? All right, so this is going to be a mega problem. Here we go. Start at the beginning. First term, 8x to the 4th. What do I divide it by? 2x squared. What is that? 4x squared. Put that at the top. And I always line it up with the terms, but that's just me. Now, there are 3 terms in this divisor, which means you are going to have to multiply and flip 3 times. 4x squared times 2x squared. Positive 8x to the 4th, right?
It's actually negative.
Negative 8x to the 4th. This is negative 12x to the 3rd, right? Positive 12x to the 3rd. Negative 8x squared, right? Positive 8x squared. Is everyone okay with that?
Yeah.
That sign flip is everything. Okay? That is the step that people get wrong. Do not mess that up. It's going to make everything wrong. And I'm going to be honest, grading these, it's going to be like all right, half right, or not right at all. So, FYI. So just bring down one term at a time. I'm leaving that plus 10 up at the top so I know when I'm done. I start over. Negative 4x to the 3rd for 2x squared.
What?
Did you get it right?
Oh shoot. Wait, Mr. Carney.
What?
Why is it -6? No!
You are going to need placeholders on these two problems. So what if there's missing terms? Use a placeholder. Good news. In long division, you should catch it if you forgot that, and I'll show you in just a second what that looks like. But in the other division that I'm teaching you Friday, if you don't have a placeholder there, you're going to get it all sorts of wrong, and you're going to have no idea that you even did it wrong. So just don't be that person. Always, always, always check both dividend and divisor that you aren't missing any terms. So let's look at number 6. So let's just check the exponents. The dividend goes 3, 2, 1, 0. Do I need a placeholder there? Anything in the dividend? No.
Yeah.
But the divisor goes 2, 0. So how do I need to rewrite this divisor?
Plus 0x.
X squared plus 0x plus 3. That's the first thing I would do. Okay? So, set it up. X squared plus 0x plus 3. Little division house thing. 8x to the third. 5x squared plus 12x plus 10. Hey, this one has like a weird remainder that's important to know how to deal with. So I'm going to put a star by it. Okay. My first step is still the same. 8x cubed, first term, divided by 1x squared, which is the first term. What's that little quotient?
4x.
Okay, hey, this is the last problem. I need y'all to chill. I know we've done a lot today. Okay, so here's how you would know if you messed up and you didn't put that 0x here. 8x times x squared is positive 8x cubed. We're going to write negative 8x cubed. So just time out for a second. If I did not put that 0x, I would be doing 8x times 3 and trying to line that up with an x squared term. So I would be able to see like, oh, wait, that's not right. I need to have that there. Now, it is a 0. What is 0 times anything? 0. But I am going to go ahead and put 0x squared, and you can put a positive, negative. The sign doesn't matter. But I do want to keep that x times x, even though there's a 0. Again, it's just keeping stuff lined up. And that's how you would know that you missed it. And then I do my 8x times 3, which is positive 24x. I'm going to put a negative 24x. So then when I add up, the first term should go, which it does, but your second term ends up being what? 5x squared, and then this 12x minus 24x is bring down the 10, and then start over. 5x squared divided by 1x squared is 5. Multiply, it's positive, write it negative. Multiply, it's a 0, so it doesn't really matter, plus 0x Positive 15 is the product. Write it negative 15. Now I want you to see this here because I said remainders can be numbers or they can be expressions. This is an expression. Negative 12x plus 0x is negative 12x. 10 minus 15 is, there's no numbers left to bring down. So this whole expression, that is your remainder. And it looks weird, but it's okay. So you still write it the exact same way. Your answer would be 8x plus 5 plus, what's the remainder?
Negative 12x minus 5 divided
Over, what's the divisor?
x squared plus 0x plus 3.
And if you go to the answer, you can put the placeholder or you cannot. Okay? So this is your answer. Okay, what are you doing next class? Review. You're getting your homework. You are doing which two sections? 6.1, 6.2. You are getting them done because you will have an hour to do 12 problems. Then make sure the sub gives you what? Both of them. Both CFUs. Don't disappoint me while I'm gone.